I am HW Dong. This is a short tutorial about Git and GitHub. Why we should use Git. Suppose you write an article. You may modify your article several times, and you want to keep some previous version of this article. How to check the modification history of a file? You may use different name to represent different version of the file, and some other people may modify this article, and you rename with their name. If there are many modifications for this article, there will be many files in your machine, and you will hard to know the difference between these files. If you work on a project, there may be many files, and each file may be modified several times. How to check all these modification history of all the files of a project? We need a software tool. Git is such a software tool. It is an open and free and open source distributed version control system, simply called VCS. Using Git, you can keep changes of all files of a project. You can coordinate workers among multiple developers. Git will record all the changes to each file in the project. Git will record who made what changes and when these changes were made. With Git, you can look back to a version of any time. Everyone can have a local copy of the whole project data. The local copy is called snapshot, and snapshot records all the information of the project and all the changes for every document of the project. When you do some work on your local snapshot or repository, you can push your local repository to remote repository, and at any time you can pull latest repository from local repository to your local repository. Here is a short history of Git. Git was invented by Linux, who is the creator of the Linux kernel. In 2002, the Linux kernel project using a tool called BitKeeper. It is a Debian system to manage all the documents and files and patches of the Linux kernel project. But in 2005, the relationship between the community and the company who developed BitKeeper broke down. So the Linux community needed a new tool to manage their project. Linux developed this tool called Git. Linux develop a Git with a goal of the following. The Git should be as fast as possible, and it should be very simple to use. And Git should support nonlinear development. That is, mean thousand parallel branches. For example, this main branch and other developer can working on another branch. Git should be fully distributed. Every developer, everyone can have a local clone of the whole project. Without a server, they can still work on this the project. Of course, the Git should handle large projects like Linux kernel. Let's review centralized version control system. Centralized VCS system has a centralized VCS server. VCS server records all the files of a project and their modification history with different versions. If someone wants to do some work on the project, he maybe check out some files from the VCS server, check out some files. Then he do some work on these files, and when he finish his work, he may check in these files, modify these files to the VCS server. So everyone rely on the VCS server. If the VCS server goes down, nobody can collaborate at all. If they do some work, they cannot submit their work to the VCS server. But with distributed VCS such as Git, everyone have a local clone of the whole project. So every clone is a full back of all the data. So everyone can work on his local clone. Everyone can work locally, and they can exchange their modification of the project. A local clone of the whole project is called a snapshot. Snapshot store all the files and all the changes over time. It is like a mini file system. People on different machines can compute their clone, their snapshot. But if there is a server, it will be convenient, although it is not necessary to have a server. With a server, computer behind the firewall or behind the internet can connect to the public server to get the latest version of the project, and they can push back their changes to the project to the server, so the other people can see these changes. If the server is down, any client can still work on their local repository. And when the server is restored, then the local repository can copy back to the server. GitHub is such a server. It is a website. Everyone can register an account on the github.com, and everyone can create their repository on the GitHub. Git is a distributed version control tool that manages development projects, all the documents, and their history. GitHub is a cloud-based platform built around Git tool. GitHub is a platform using Git tool to manage a repository. Git is a tool a developer installed locally on their machine. And GitHub is an online server that stores repository, the codes or documents of a project pushed from local machine to the GitHub using Git tool. Okay, this is a short history of Git and GitHub. Let's install Git. If your system is Linux, Debian, or Ubuntu, you can use this command to install. If your system is Fedora or CentOS Linux, you can use this command. If your system is Mac system, the Git has been installed on your machine. You can also still using the installer from this link to install latest Git tool. For Windows, you can download the Git from this link. I have downloaded, my machine is Windows, I have downloaded this tool. You can download this or this. I have downloaded the Git tool, this. Then I double click this program to install Git on my Windows system. Just next. Okay, Git is installed. When Git is installed, you can configure your Git setting. We generally configure with this option. Global means user setting. You can also, with this option, system, to configure your system setting, or you can use this option to configure repository specific setting. Each option corresponds to a configure file. We generally configure global username and global user email. You can use this option list to list all the Git configure setting. Git setting. You can also add this option to list all the global setting. You can also unset some configure, or that means remove some configure using this option. Unset. This command remove repository configuration, and this option remove global configuration, and this option removes system configuration. Okay, we can open Git. There's this using git configure list to list all the git config. You see, I have configured my email and name. If you want to remove, you can use the git configure unset global unset use the name. Use the name is removed from global setting. You can also set it again. You see, username is configured. Now we'll talk about how work locally with Git. To work on your machine, you should create a local repository. Your local repository should work directory. Your machine should work directly. You put all the files in this directory, and you modify a file or add new files to a directory. Then you will add these changes to a stage area. Stage is also called index. Finally, this is called a stage change. Make change to stage area. Finally, you should use commit command to make these changes, stage changes to the Git directory, also called Git repository. So there are three things: working directory. There will be some files, and you will modify files in the work directory, but these files and modifications have not been separated to the Git directory unless you use add and commit command. After you use commit to put your change, to store your change to the Git repository, then Git repository will remember or record your change. So this is a two command, add and commit, two main command we often used. Here is a general local Git workflow. First, we create a directory and enter the directory. Then we'll create a Git repository in the directory using a command called git init. Then you will do some work in the current directory, such as create new files or modify some files. Then you should add changes to stage area using git add dot. Dot means add all the changes in the current directory to the stage or index area. Finally, you should use git commit command to commit all your changes in the stage to the repository. With this option, you can give some comments, such as you add a new file. This hint when you later to check what's the meaning of the commit, you can see the comments attached to the commit. These three commands, these just need done once, just when you often use the command is git add and git commit. Sometimes you may use git status to check the current state of your repository or your stage or your working directory. If a new file is created but did not use add, then the file will be status untracked. If you use add for the file or for some change of a file, then the state will become staged. If you submit all your changes to the Git repository, then the state will become committed. It means all your change is committed to the repository. You can view all the commit history in the repository using git log command. You can view a command change, what change of a command using git show. You can also using a command git reset to loop back to some commit at end time, to loop back to end time commit. Now we will see an example of how we work using Git in local machine. First, we using cd, go to the root directory, then make a directory called my project, and enter cd this directory. That is done. We can see on the file explorer. That is launching. To make this directory become a Git repository, we should use git init. Just once initial empty Git repository in Git directory, my project .din git. We can see here, this is a Git repository directory, recorded all the files and change or commit change in this directory. We use to touch.a.din.txt to create a new. Then there will be a.text on this project, but this file did not have not added to the repository. We should add this file to the repository. First, we should use git add dot means all the file in the current directory to the stage. Add to stage. You can use git status. Not committed yet. Not commit. Change need to be committed. So we use git commit. Create. Then nothing to commit. The working tree is clean. Working tree is clean. All changes has been committed to the repository. We modify this file. This is a VM edit. You can use the type I on the keyboard to enter the insert model. Then you can type some. Then you type yes key on the keyboard to enter the command model. And then type column key, WQ to save your changes. Change not staged for commit. You made a change to this file, but this change has not been staged. We should add it to stage. See the status. Changes need to be committed. Has been staged but not been committed. We should commit it. Git commit. Hello. Nothing to commit. Working tree is clean. This is a local workflow. General work. You can use the git log to see all the commit. This is the first commit. This is the latest commit. We add a hello. The first commit is create a.text. Each commit has a ID. This is a hash value ID. We do some type I enter insert model ABC. Type ESC to enter the command model. Type column WQ to save this change. Git add git commit ABC. We add ABC on the second line. Git stat git log. We can use git show. Git show shows the latest commit changes. This we add ABC. So there are 3 commits we have done. This is the latest commit. If you want to loop back to the first, we should use the git reset. Hard means we will loop back Git repository and stage and working directory. All the three will reset to a version. Header is a pointer to the latest commit. We use these to loop back to previous two commit. Header pointed to this commit. Header plus this symbol means this commit. Header plus 2 symbol means this. This means we will loop back to this commit. There is just one commit. We create a.text. We are let's see this PowerPoint commit history like this. This is the first commit, second point, 3 commit, fourth commit. Repository recorded all the commit history, and this development line has a default name called master branch. This is the main branch. And there is a header pointer to point to the latest commit of the repository. If you want to loop back to previous commit, you can use git reset to this symbol. You can also use this means we loop back from this header pointer to loop back to commit. The two command is equal. Okay, the header point to the latest command. This is the last command of the repository. We can also loop back to this command. This commit. This commit has an ID. We should give its ID. Git reset ID. Git reset has a model and commit ID. Commit ID can be header or header. Model means we do operation for repository or stage or working directory. This means we just modify the repository. This means we not only modify the commit history but reset the stage. We can also reset working directory, stage, and repository. The model option has this soft mixed. We generally using harder. Harder means to reset the index and working tree. Include the repository. Now we will git reset hard to this ID. Now we can we look back to the latest this ID. There are 3 commit. We look back to this. There are 2 commit, the first and the second, but the 3 is discussed. We will look back to the 3 committer. This committer. Last time we use a 4 ID. In fact, we just read 3 ID is okay. The 3 letter of the ID. 3 letter. D for 3. Okay, we look back all the 3 commit. Okay, this is the general local workflow of Git, local Git workflow. Now we talk about working with branch. Branch option allows create another line of development. You can use this operation to fork off the development progress into 2 different directions, or 3 or 4 different directions. For example, in this figure, there is a main branch called master. You can fork off another development program along this branch. And when this branch is done, you can merge this branch to the master branch and delete this branch. Git branch command to list all the branches. And git branch for a branch name, use create a new branch. For example, git branch another will create a new branch. New branch has the same commit as master. Then we may work on the master, push some, submit some commit, and on the another branch, you can do some work. If this branch, you don't want this branch, you can use git branch, this option, branch name, to delete this. Also, you can use this option. These 2 options have some difference. This means safely delete the branch. This means force delete the branch. Safely delete the branch means if this branch has been merged to another branch, then this branch can be deleted. If this branch has not been merged, then if you use this command, the branch will not be deleted. But this will always delete this branch, no matter whether you merge this branch. whether or not you have merged this branch to master. This option will always delete this branch. If there are more than one branch, you can use checkout to check out a branch to switch between different branches. You can use git checkout with the option and branch name to create a new branch and switch to this branch. You can use git merge to merge a branch to another. For example, we first using checkout master to switch to this branch and then to merge another to this branch. Git merge another branch to the current branch we are working. If using this command, then the branch is merged to the master, and this is and the another branch is the same. You can delete another branch. But in this case, the master branch has some commits and another branch has some commits. If you using merge, there may be some conflict. You should manually solve the conflict. We'll give some example. To list all the branches, there is only one branch master. The star means this is the current branch we are working. We create a branch using git branch name. Now there are two branches. Another is a new branch, but we still working on master branch. We can switch to another branch using checkout git. Switch to the branch another. We can use the git branch to see we are working on another because the star is on this branch. We can see the adding text in this branch. We do some type I, we enter the insert mode, we do some work. Then we type esc to enter the command model, save. Okay, for another branch, we do some work. It did add text, but this change has not been staged and commit. We should use git add. Git. Okay, we check out master. We see a .text in the master branch. Now we want to delete the another branch. We want to delete this branch. it is either the branch is not fully merged because it's not merged, so we can't delete this branch. But we can use git this option. The branch deleted branch another. You can see there how many branch, just one. Okay, we create another branch by check out this option. This will create a branch and check out switch to this branch. Now we are working on this branch. This branch text is same as the master branch. Now we edit this. Type I to enter insert model. ESC to enter the command model. Column WQ save. Changed. A.text changed. We should add the change to stage. Commit the change to repository. Now we can switch. Switch to the master. chgck. Check out master. Check out master branch. Switch to the master branch. In master branch, a.text is as before. Now we will merge another branch to the master. We are working on master branch. We can use git merge to merge another branch to current working branch. Another branch to current we are working master. This means we merge another branch to our working branch master. Now we check a.text. A.text is changed because another branch a.text is merged to the main branch, to the master branch. Now we can delete another branch. Just one branch. When we merge, there is no conflict. We check out another branch and create another. Cat. Now we are type I change this to XYZ. Type JC to enter the command model. Save. Now we check out master, and we edit it. Check out a notification. we haven't add and commit. We forgot to XYZ. Commit change to the another branch. We check out a.text is this. Type enter instead. We do some change. Add change to stage. Commit change to repository. Now we start to merge another to this branch master. It is a merge conflict. You should solve conflict this issue the conflict. This current branch is a.text. This is another. We can manually edit this. So now we merge again. We have not add to the master. Okay, when we solve the conflict, then we can merge another to the master. This is example how to work with branch. We use git branch to list all the branch or create a branch. We use this option to delete branch, or we use the checkout to switch branch. Checkout can also create a branch and switch a branch. And we can use the git merge to merge another branch to current branch. If there are conflict, we should manually solve the conflict and then use the merge tool. Merge tool from to branch. Until now, we are working in our local machine. We often working with GitHub to store our repositories. GitHub repository is on the GitHub website. This repository is called a remote repository. This is remote repository, and every local machine can pull repository to his local machine. When he do some work, he can push back local repository to remote repository. GitHub store and manage Git repositories. Everyone can register a GitHub account to create a repository and work only GitHub without a local repository. But people often like to work with local repository. It is convenient. When they do their work, done their work, they can push local repository to remote repository. We generally clone a repository from GitHub to our local machine. This is a local copy of the remote repository. When we do some work with the local repository, we can use push command to push local repository change to remote repository. At any time, we can pull latest version from the GitHub to your local machine, because someone may do some new updated to the project. We can pull the latest version. This is 3 commands we often used. This is a figure how we working with the GitHub remote repository. This is a local machine workflow. In local, we working in directly do some changes and using adder to add change to a stage, and then using git committer to commit the change to the local repository. At any time, we can check out a branch from the local repository, do some work. We can also using git merge to merge 2 branches. When we have done some more work on the local repository, we can push local repository to remote repository. We generally create a repository on GitHub and then using git clone to clone the GitHub repository to our local machine. If we have not any local repository, we generally create a repository on the GitHub and then using git clone to get a local copy of the repository to a directory of local machine. We can push the local machine we can pull repository from GitHub to our local machine. Bare repository is a repository without a working tree, just a repository. GitHub used to store bare repository. You can using git init this option to create a bare repository. Bare repository just this without working tree. We generally to work with GitHub, we generally create using the plus button to create a new repository. For example, we create a repository called a test. You can make your repository public. Anyone can see the content of your repository. You can make it private. Just you and your friends can see the private. To create a repository, if your local machine has no any local repository, you want to create a repository on the GitHub, you should click this, then create a repository on the GitHub. Or click this button. This is your remote repository web URL. You can copy it. Also, you can click this button to copy the web URL. Then on your machine, I close it. I open Git tool. This is a root directory. You can use a git clone to clone the GitHub to our local machine. This is a test. A readme is only one file on the GitHub local machine. It is cloned to our local repository. We can also see on this. Now you can do some work on this local repository. Git. If we do some work on our local machine, we can push our changes to the local repository to the GitHub using git push. First time you're using git push, we'll ask your GitHub account. Okay, we refresh the GitHub. You see the a.text is committed to the GitHub repository. Let me see the git push command again. We see the git clone. Git clone the command create a local repository named origin. We use this clone to clone this repository and give a local repository name to this cloned repository. This name is default. The default set by default name is origin. Origin link to the remote repository. And the remote repository is a main branch called master. We can use git remote to show the URLs has stored for the short name. Git remote remote shows all the remotes, just one. The orange is a remote repository in our local repository. Show its URL. Its URL is this. The push command can have two parameters. This is a repository name, and the another is a branch name. The repository name is default set origin. The branch name is default is master. Now we do some change to the local repository. We can push origin, push this remote repository named origin to the remote repository branch master. This command is same as this. You can see this file is changed to a header folder. Now we will change this file on GitHub. Commit changes on GitHub. We change directly on GitHub. If our local repository is not latest, we can use git pull to pull the repository from GitHub latest version to our local machine. Now we check the ABC. Now the local repository is same as a remote repository. If we want to put our existing local repository to GitHub, we can create a GitHub. For example, my pro test 2. This time we create a new repository without click the initial, because there are existing local repository in our machine. We want to push its content to GitHub, so we should not click this. We just create a empty repository. It gives you some hints. You can use git remote add to add this repository to a local repository. We enter to our local repository. This is our local repository. We can This is our local repository. We want to push its content to the remote repository. The first thing, we should add the remote repository to our local repository. Establish a link using git remote add. Add a new remote Git repository as a short name, root repository, GitHub web link URL using git remote add to our local repository. Now we add the remote repository to our local repository. Give it a short name original. Then we can using push our local repository to the we'll push our local repository to the GitHub GitHub repository master branch. Okay, we check our test. Oh, you see, local repository a.index b.x has been pushed to the GitHub remote repository. You can using git fetch to fetch data from a remote repository. For example, using git fetch original. I do some work. But we generally using git pull because git pull do more work. It first using git fetch to fetch data and then merge two branch. Okay, this is a short tutorial about how working with GitHub. The often used command is git pull to pull latest version from GitHub, git push to push local repository to remote branch, and git remote add to add a remote repository to our local repository. Just establish a link between our local repository and the remote repository. If you have not any local repository, you can directly create a GitHub repository and using git clone to clone GitHub repository to a local machine, a local empty directory in your local machine. This is a short tutorial about Git and GitHub. If you are interested in my video, you can check out my YouTube channel called HWDNG. Thank you for watching my video.